Hi, welcome to the AJ Tutoring channel. My name is Rachel and I'm here today to talk to you about chemistry and intermolecular forces, also known as IMFs. Before we get started, make sure you like and subscribe. Now, let's dive in. In intro chemistry, we usually discuss three types of intermolecular forces: hydrogen bonding, dipole-dipole, and London dispersion forces. These intermolecular forces, also known as IMFs, result from the polarity within a molecule, but they actually tell us how they interact with other molecules around them. First, let's start by looking at HCl. If we look back to the electronegativities of hydrochloric acid, we see that hydrogen has an electronegativity of 2.20 compared to chlorine's electronegativity of 3.16. This difference in electronegativity, you may recall, results in a polarity where we see the electrons shift from the hydrogen to the chlorine. This imbalance in sharing electrons causes a partial charge to form on both the hydrogen and the chlorine, where the hydrogen forms a partial positive charge and the chlorine forms a partial negative. This means that when another hydrochloric acid molecule gets close to this one, the positive charge will attract a negative charge and the negative charge will attract a positive charge. This attraction between the positive and negative forces results in these two molecules sticking together. Very similar to hydrochloric acid, we can take a look at the water molecule. Now, in water, hydrogen maintains that 2.20 electronegativity, but oxygen has an electronegativity of 3.44. Similar to hydrochloric acid, this results in an uneven sharing of the electrons, which causes a polarity to form, where oxygen is a slight or a partial negative, and hydrogen is a partial positive. However, water is a special molecule. Whenever hydrogen is bonded to an oxygen, a nitrogen, or a fluorine, which many teachers will refer to as NOF or FUN, it forms a hydrogen bond. This is the strongest kind of intermolecular forces, and it only occurs if hydrogen is bonded to nitrogen, oxygen, or fluorine and interacts with another nitrogen, oxygen, or fluorine. Finally, we're going to talk about the methane molecule. In methane, the hydrogen maintains that 2.20 electronegativity, and carbon has an electronegativity of 2.55. Since there's a very low difference in electronegativities, this means that they share their electrons evenly and no polarity forms. As a result, there are no partial charges, which means that these kinds of molecules, where we have London dispersion forces, do not interact very strongly with other molecules. Thank you so much for watching this video. I hope you found it useful. If you are looking for help in other topics, please make sure you check out our AJ Tutoring channel. I'll see you next time.